All right, hey, it's Horner, and this is a roller coaster. And so up at the top, we know that the roller coaster has potential energy due to gravity, and down at the bottom, it has kinetic energy. So if we want to know the work that was done, at the very top, remember, since it's all potential, there's no kinetic energy here. So this is 0 joules. But down at the bottom, I do have kinetic energy. So if I found out what the kinetic energy is at the bottom and subtracted it from 0, then that would be work. So work here is equal to the change in the kinetic energy. However, I could also start with potential energy due to gravity, and I know that down at the bottom, the potential energy due to gravity is equal to 0. So I could also say that the work here is equal to the change in the gravitational energy. If I actually want to find work that the spring does, I can say, well, the spring doesn't have any energy right before the cart hits it, but after it hits it, then it would have energy. So your original spring energy would be 0, and then your final spring energy would be 1/2 kx squared. And the difference between those two would be work. So that's also change in spring energy. So when you look for work, you don't have to use kinetic energy, but it works pretty well. So that's kind of the cool part with it. So you'll see change in kinetic energy mainly used, but you can use any of them. So you could use change in potential. Here we used change in spring energy to find out how much energy is used to stop that cart. And hopefully that helps.